Welcome to lesson 48 of our interactive notes. We are multiplying whole numbers to fractions, word problems using models and equations. So we're going to look at some more word problems, pages 45 and 46. So here we have our content objective for 4th grade, NF, numbers, operations, fractions, B.4c. I can solve word problems involving multiplication of a fraction by a whole number using visual fractions or equations. Language objective. I can use vocabulary related to fractions to communicate how to solve word problems involving multiplying a fraction by a whole number. Social objective. I can work with others to create models to prove how to solve the word problem involving multiplying a fraction by a whole number. On the first two examples here, we have models, so we have drawings here to help us out to solve our problem. But anytime we approach word problems, we're going to use our cubes. So remember, cubes stands for C, circle our numbers, U, underline our question, B, box keywords, E, eliminate unnecessary information, and then S, solve. So we're going to use those. So I'm going to circle my numbers. Sally baked cupcakes for 9 of her friends. 2/3 of her friends want vanilla icing on their cupcakes. How many cupcakes will have vanilla icing? So we want to know how many will have the vanilla. So she has 9 friends. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 cupcakes. 2/3 want vanilla. So this first row here is cut into 1, 2, 3. There it represents 3. So 2, 1, 2 out of 3. We look at the next row. There's 1, 2, 3, so we need to represent 1, 2 out of 3. And then our last row represents 3, and we need to do 2/3, or 2 out of 3. If you don't have your highlighter, you could use a pencil to color those in. So how many cupcakes do we have that will have vanilla icing? 1, 2, 3, 4, 5, 6. Out of the 9 friends, 2/3 of them. So if you're putting them into groups of 3, 2 out of each of those 3 will have the vanilla icing. So that's a total of 1, 2, 3, 4, 5, 6. 6 cupcakes will have vanilla icing. All right, so here there were 12 children at the costume party. 2/6 of them were dressed up as their favorite superhero. How many superhero costumes were there? So we want to know how many were in superhero costumes as opposed to those that were not. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Our 12 friends represented. This first row shows 6 of the friends. And out of those 6 friends, only 2 would actually be dressed as their favorite superhero. Then here, out of these 6 friends, 2 would be dressed as their favorite superhero. So out of all 12, how many are dressed in their favorite superhero costume? 1, 2, 3, 4. There were 4 superhero costumes at the party. Because out of the 12, out of this group of 6, there were 2. Out of this group of 6, there were 2. So a total of 4 out of all 12 children. So that's using a model to help us solve the problems. Now we're going to look at using an equation. Here it says write an equation to show 5 times 3/4. So one way to turn it into an equation, well, you have to have an equal sign. So 5 times 3/4 equals, but since we don't know what it is, we could just put a letter here called a variable to represent the result. I'm going to put n for number. Always multiply the whole number by the numerator. So a way of looking at this, so I can flip this equation around. I can also write it as n equals 5 times 3/4. That is called the symmetric property of equality. So you can write it either way. It means the same thing. A way to look at 5 is there are 5 whole units. So 5 over 1 we can write, because there's 5 of the whole thing. And if you forget what you're multiplying by, you could just multiply straight across. 5 times 3 is 15. 1 times 4 is 4. That way you remember that it's just the numerator that's going to be changing in this case. So that could be a good way to remember what needs to be changed. And then here, I can get 3 whole groups of 4 out of 15. 4 times 3 is 12. 15 take away 12 leaves 3. So answer, n equals 15/4. That is true. May not be the most useful way to look at the number, but if I knew I had 3 whole and 3/4, that may be more useful, but both are correct. Now we're going to check our answer by actually drawing a model. So let's go ahead and get down. Let's make 5 whole units. I'm going to make squares cut into fourths. Kind of looks like a bunch of windows. Okay, so I'm going to color in 3/4 on each. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I have 15 of those fourths. Or if I decided to give this one here to this, color that in. Give this one here to this one. And put this one, so like if this were a pizza box, each of these were all missing a piece, I could put these pieces in those other boxes to fill them in So I could throw away that trash so I don't have too much. And I have my 1, 2, 3 whole units and 3/4. So they mean exactly the same thing. So here let's look at a word problem, and we're going to use an equation to help us out. Martin is buying food for a party. I don't really need to know that. That's just extra. He estimates that each person at the party will eat 1/8 of a bag of chips. If there are 18 people coming to the party, how many bags of chips should Martin buy? So I need to know how many bags we need to buy. I'm going to use B for my equation since we're looking for bags. And I have 18 people that are going to eat about 1/8 of a bag of chips. Okay, so to solve this, well, this 18, I could say 18 whole units. Why did I put 18 down there? That should be 8. So 18 times 1 is 18. 1 times 8 is 8. Those are both even, so I'm going to simplify them. Half of 18 is 9. Half of 8 is 4. I could get 2 whole groups of 4 out of 9, because 2 times 4 is 8. But then I'm left with 1 piece. So I need 2 1/4 bags. Do stores let you buy 1/4 of a bag? No. So we have to figure out what would be a reasonable answer. Martin needs to buy, he needs to buy 2 full bags, and he only needs 1/4 more. But will a store let you open a bag and only take out 1/4 because that's what you need, or does it want you to buy a whole nother bag? So should we get just 2 bags and have some people hungry, or should we go for 3 bags? Martin needs to buy 3 bags. Now, if you notice, our answer was 2 1/4, but we've got to think about the situation. If we're buying a product, stores won't let you take a fraction of it. So you've got to make sure that our answer makes sense to what we're talking about. Martin needs to buy 3 bags. Between what 2 numbers does the answer lie? The answer lies between the whole numbers. So 2 1/4 is between the whole numbers of 2 and 3. So we could decide to go with just 2 bags and have some people hungry, or go with 3 bags and have some left over. That's what it means between lie between. What fraction, what is this mixed number between? It's between 2 and 3. And see how this mixed number made it a little easier to answer than leaving it as an improper? All right, let's go ahead and keep practicing with our 3-column